What do you think the future will look like? This? This? Or will it look something like this? Climate change is transforming the way we think about the designs of our cities. We're typically used to thinking of the future as a shiny concrete jungle, but this is looking less and less likely, at least not until we've solved a huge problem first. This stuff. Concrete. The foundation of, well, foundations. Concrete has a lot going for it. It's cheap, reliable, and so easy to use that basically anybody can be taught to work with it. So it's no surprise it became the defining architectural feature of the last century. So whether you're a fan of brutalism or you just think architects have actually been walling us in a concrete prison, either way, concrete is a really useful material. Problem is, it's threatening the future of our planet because of its absolute dependency on fossil fuels.
You couldn't possibly make it on anything like this scale without enormous fossil fuel inputs.
So the search is on for alternative materials that can offset concrete's carbon footprint. And while looking ahead to the future, many are actually delving into the past for inspiration. But one thing does seem certain.
We cannot build in concrete and steel any longer.
So what exactly is so bad about concrete?
Concrete is a big part of the problem. It's around 8% of all carbon emissions at the moment.
These emissions are largely caused by one ingredient: cement. While cement makes up just about 10 to 15% of concrete's total mass, it accounts for up to 90% of its greenhouse gas emissions. But despite this huge carbon footprint, we're making massive quantities of this stuff.
The total amount of cement we make on the planet every year at the moment would require you to cover an area of the size of Australia in woodland.
But with a global population of nearly 8 billion and an anticipated rise of 2 billion more over the next 30 years, the demand for housing, and by proxy concrete, is only getting larger.
In the 3 years of its peak building boom of around 2013, China used more concrete by a long way than America had used in the entire 20th century.
And that's the central conundrum of concrete. Whilst it's contributing massively to the rise in global temperatures, it's also difficult to find a sustainable alternative capable of building on such a scale. But one possible solution, a material that's both recyclable and plentiful, might be just beneath our feet. Mud. Mud brick construction has been around for centuries, but perhaps surprisingly, many of these old earth architecture structures are still standing firmly today, such as this, the Gingerba Mosque in Timbuktu, Mali. Erected in 1327 and built almost entirely using materials such as fibre, straw and wood, and still standing today. It's a prime example of the durability of earth building. But how exactly does this method work?
So earth building is a historic, traditional technique, and it's all about using some kind of soil in buildings. For the most part, that means subsoil. So that's getting into the mineral bit of the soil. There's always going to be some clay within that subsoil because clay is the sticky binder that holds everything together.
The clay can then be easily moulded into different shapes for use in the walls, making it totally cement-free, and meaning it has drastically lower carbon emissions. But rammed earth also has another trick up its sleeve. It's excellent at regulating both temperature and air quality, keeping the inside cool in the summer and warm in the winter.
Clay is a hygroscopic material, so it likes to take in moisture. When there's a lot of moisture in the atmosphere, it's absorbed into anything that's made of clay and then slowly released later. So it has this beautiful effect on humidity in any part of the house where it levels it off.
This makes rammed earth a potentially attractive prospect when it comes to small residential units. But what about skyscrapers and high-rise flats? Can this ancient technique be unified with modern architecture? Well, the answer is complicated. There are stunning examples of earth architecture being utilised for tall buildings, such as the Yemeni town of Shibam, which was largely constructed in the 16th century and is sometimes referred to as the oldest skyscraper city in the world. Some of the buildings in this city of mud are over 30 feet high, and the fact they're still standing some 500 years later shows just how durable earth architecture can be. But unfortunately, this ancient material faces an equally ancient adversary: water.
So where we might get a problem is, say if we had a leaking gutter where there's constant water coming through, then eventually that little bit of water tracking through can break down the walls and you can get bits of collapse that way.
In Shabam, this water damage is mitigated by routinely applying fresh coats of mud, but this method of preservation is better suited to warmer climates. Not so much the constant rain that is typical of European cities, meaning the maintenance of large-scale structures may not be so viable. So to build our future skyscrapers, we may need to turn to a different material: timber.
We need to think really carefully about how we can change the way in which we build. The technology exists, the materials are there, so this is an opportunity to really make a big difference relatively quickly.
This is Andrew Waugh, who's designed the office group's black and white building, which is made entirely of timber. Standing at just over 58 foot high, it's the tallest mass timber building in central London.
So you can see from this building, each one of these wall panels arrives on site millimetre perfect. So we're not throwing anything away at this building site. There are no big skips full of rubbish outside. And in the UK, about 50% of our landfill is just from construction.
And the key advantage of timber is that it's regenerative.
You can grow more of it. So it's not an extractive process. We're not scraping something off the surface of the planet, of the Earth, which we will never be able to put back. Every tree that's cut down, 5 are put back in its place.
Now you might be wondering about fire safety, and that's something that's certainly not lost on timber architects either, both the actual risk and the public perception.
One of the primary issues that we face is a concern around fire. And we work very closely with fire engineers, with different research departments globally, so that we're really careful about how we instill those in our buildings. And I live in a timber building on the 7th floor with my family. This is very close to me, ensuring that the buildings that we build are safe.
Timber seems like a genuinely exciting and viable solution to the future of how we build our cities. But there is a limitation. It's not going to replace concrete entirely, not least for major infrastructure projects.
We will probably always need concrete, for the infrastructure, for bridges, tunnels, for the foundations of the buildings that we build. But we need to transform the industry to one that vastly reduces the amount of carbon that it emits.
The central issue all comes back to concrete. As long as it remains the cheapest, strongest, fastest, and most versatile building material, which it is, we're not going to eliminate it entirely. So what if we don't have to abandon it altogether? What if instead there was a way to recycle it and make it more sustainable? And that's exactly what Dr. Pippa Horton has been working on.
So I've got here a piece of one of the very first batches of cement that we produced. And how we make this is you take old concrete and you separate out from the concrete the aggregate and the sand, and what you're left with is old cement. And in order to turn that cement into new cement, it needs to be heated at very high temperature. We're using an electric arc furnace, which is a really hot furnace used for melting metal. And we put our old cement paste into that equipment, heats it up and turns it back into new clinker. And then we get to process it and recast it into new cement.
Put simply, this means recycling the cement we have to produce new variants in an almost loop-like process. But with this cement being sourced predominantly from demolition waste, is there enough to make this viable?
So there's enough demolition waste at the moment that we could meet the needs of about a quarter to a half of global cement using this production process. So it couldn't completely replace it, but it would do a pretty good job of meeting some of those needs without emissions. We're aiming and we hope that this process can be completely carbon-free and we eliminate all the emissions. We think we could save 500 million tonnes of CO2 a year from doing this process if we did it at full scale, so perhaps a couple of percent of global emissions, but they're really rule of thumb approximations.
Innovations like this, trying to transform concrete from within, could be the key to making the future of construction sustainable. But beyond reusing concrete, there's also the option of reusing the things we've already built. It's called retrofitting, which is repurposing buildings rather than tearing them down and replacing them with more concrete.
We have a very, very large stock of existing robust buildings. 80% of the buildings we'll have in 2050 are already up by a conservative estimate, and almost all of them are performing really badly in energy terms, so we need to sort them out. Sorting out an existing building is very much lower carbon in almost all cases than building a new one.
It's very unlikely there'll be a one-size-fits-all solution when it comes to concrete. So rather than our future cities looking like sci-fi utopias, or dystopias depending on your particular aesthetic, our future skylines are likely to look more like a collage, with exciting new innovations sitting alongside some of the surprisingly durable techniques from far back into human history. An exciting way to keep history visible, while also ensuring we don't demolish the future in our rush to keep building.